Today we're doing operations with polynomials. And the operations are addition, subtraction, multiplication, and division. Those are our basic operations. So the easiest way to do this is to just dive in and swim. But the weird part about this operations with functions is they ask us to note any restrictions in the domain. So basically they got two functions for us, f and g. And they're asking us to add them together, subtract them, multiply them together, and divide them. But sometimes weird things happen. So what we'll do is we'll go to the original guys, and here's how I like to think of this. I like to think of it as two different people. One of the people's name is F, the other person's name is G, and each one of them are having a party separately. Right? They're having a party at their house, and they need to invite their friends over, invite people over, right? And you guys have at least been around enough to know that sometimes there's a few people that you don't want to come over to your party because they cause trouble. You know, it's nope, we ain't inviting this person over because they're a troublemaker. Those are what we're going to call restrictions in the domain. Those are troublemakers for us. So let's look at F right now and just kind of see who F wants to invite to their party. And here's the basic idea, is if you see any variables in the denominator of a fraction, right, downstairs, any variables in the denominator, that's bad because the first commandment of mathematics is you can't divide by 0. And, you know, if we end up dividing by 0, bad things happen. The other thing that is weird is if we have any even radicals, you know, like a square root or a fourth root or stuff like that. Would you realize you cannot, take the square root of negative numbers or things like that? So really, those are the only two troublemakers that we're looking for, is variables downstairs or if there's any even radicals. So let's do this. Let's look at F and see who he's going to invite over to his party. Is this X downstairs? Is it in the denominator? No. Is there any even radical around that thing? So everybody's invited over to F's party. Let's put a little all reals right above that. Every real number of X can come over. Nobody's causing problems if they get invited over to F's party. And if you go over to G's party, would you look over that there's no X's in the denominator, and you don't have any even radicals or anything like that, so everybody's invited. Come on over, right? And then what happened was F was having their party, and G was having their party, and they, you know, got through the social media and said, hey, let's combine these parties together. You know, let's do this. Let's bring us all together. And let's play games at these parties. You know, it's you can play weird games like Monopoly or Twister or stuff like that. Well, the games that these people are going to play are called addition, subtraction, multiplication, and division in this case. So first game that's going to happen is these two parties that are coming together and they're going to play addition. So they ask us to add these together. It's a simple game. We'll take F, which is 9x minus 3, and add it to G, which is 3x plus 12. And this is pretty simple. Can't we combine some like terms in this case? Wouldn't that give us 12x plus 9 in that case? So this is what happens when those two groups played the game of addition. And I'd like to know if there was any troublemakers when that happened. Did anybody get in trouble? And since there are no x's downstairs and there's no even radicals, everybody got along when they played the game addition. No trouble happened at the party in that case. So nobody got kicked out. You okay with that? So no restrictions in the domain. Now let's play the game of subtraction. Said, okay, we'll take F since he comes first, and that's 9x minus 3. And we need to subtract away G. Remember, when you subtract away a binomial, you have to put it in parentheses. So you can just watch me if you want for a second. We got to subtract this whole thing away. And then the next move is to distribute the negative through the parentheses. So doesn't that basically just change the signs of this dude? So instead of you writing subtraction with the parentheses, why don't you just change everybody's sign in this dude in the first place? Because if you subtract it away, that happens. And let's see if everybody got along. We combine like terms, and you get 6x minus 15. Would you believe that when they played the game of subtraction, nobody went downstairs? Right? So nobody got in trouble down there. And there were no even radicals in the first place, so everybody got along. Nobody got kicked out of the party in that case. And now, multiply. We will take f, which is 9x minus 3, and 3x plus 12, and we need to multiply them together. And since that's a binomial times a binomial, we'll FOIL it, right? So let's FOIL that guy out. First terms times each other would be 27x squared. My pen would work. Outside, help me out with the 9 times 12. That's 98. Is that 108x? Is that right? And then minus 9x minus 36. And please take 108 minus 9 for me so we can get that answer. What do we get? What's 108 minus 9? 99, and it's positive. 99x's minus 36. Do you think anybody got kicked out of the party when we played the game of multiplication? Did anybody go downstairs, or did any even radicals show up in that case? So far, all these games are real safe. You know, adding is a safe game, subtracting is a pretty safe game, and multiplying is a safe game. But you know, there's that one game at the party where it's just like, uh-oh, if this shows up, some people are going to get in trouble. And this game is called division. All right? The division game can be dangerous. Not for everybody, but just for those few people that are just kind of on the border of this invite list. So let's see what it looks like. Let's take f, which is 9x minus 3, and divide it by g, which is 3x plus 12. And this is why this is a dangerous game, because didn't somebody have to go downstairs? And as a party, that's usually where some of the bad stuff happens, is when people go downstairs and nobody's watching. So, we've got an x in the denominator. If something makes that 0, the party is going to be bad, right? So what we need to do is figure out who the bad guy is. Who is the dude that we cannot allow to go downstairs? What value of x makes this 0? Well, if you're not sure, we could go off to the side if you wanted to and say 3x plus 12. We do not want him to equal 0 in this case. And like solve for x. Wouldn't you subtract 12 over and then divide by 3 in this case? And what does this basically say? That x cannot equal negative 4. Negative 4 is a bad dude. Since negative 4 went downstairs, if he goes down there, he's going to make like a bomb go off at the party, and we don't want that. So we said, you are kicked out. We have to kick negative 4 out of the invite list in this case. So it says x cannot equal negative 4. Then we also have to see if this can clean up, just like we did last class, you know, where we kind of factored and canceled and stuff like that. We need to see if we can clean this up a little bit. But you always kick people out of your party before you clean stuff up, right? Because they're going to cause problems. So look at the numerator. Would you believe, is there a GCF you could take out of the numerator? What would that be? 3. So let's take the 3 out. And you're left with 3x minus 1, right? And then how about downstairs? Is there something we could clean up? 3 could be a GCF that we take out of there. And that would be x plus 4. And that, now we can clean that up because can't these 3's over 3's cancel in that case? And that even shows further that negative 4 is a bad guy at this party. And negative 4 totally makes that denominator 0. Remember, we can't start canceling like x's with x's now because these are binomials. It's got to be the same group on top of the same group. But when f and g combine parties, and if they want to play the division game, somebody has to get kicked out. Otherwise, we're going to have to call the cops in that case, you know, because if negative 4 goes downstairs, he's going to make the denominator 0, and that can't happen at my party, man. You know, we can't have that happening. My parents will be mad at me. So let's try that again. First, before we play any games, we got to see who's invited to the party in the first place, because some people are all automatically kicked out of the parties before you even play games. So how about F? Is everybody invited? Or are there any troublemakers? You're looking for x's downstairs, or any even radicals, like square root, fourth root. Do we have any of that stuff? So everybody can come over to F's party. Cool. How about G's party? Do you have any x's in the basement to start with, or any even radicals, like square roots or anything like that? Not squared, square roots. Do we have any of that? So everybody's invited. Cool? And let's play our safe games of adding, subtracting, and multiplying. They'll be pretty safe. So let's add these together. This is x plus 1 plus x squared plus 3x plus 2. And then we just combine like terms. And let's put it in standard form. Let's put the squareds first. Then we have 4 x's. And then we have 3 constants. Right? And nobody gets kicked out of this either. When they played that game, nobody went downstairs. No even radicals showed up or anything like that. So everybody's still cool. No restrictions in the domain. Let's subtract them from each other. What order? F's first. So we'll do x plus 1. And then to take away all these other terms, everybody's sign changes. So that's like a minus x squared, minus 3x, and a minus 2. It doesn't mean they all become negative. All the signs change. And in this case, they all became negative. So combining like terms, it'll be negative x squared minus 2x's, and then minus 1, right? And would you notice that when they played the game of subtraction, nobody went down to the basement, no even radicals showed up, so everybody's still getting along, right? Nobody gets kicked out. Now let's multiply. Yay. Let's take this binomial times this trinomial. And we kind of did a little bit of this last chapter. Let's refresh our memory before we end up combining like terms. If you take 2 dudes times 3 dudes, shouldn't you get 6 dudes back? All right, so let's do that. Let's take this x times every one of these red guys. So x cubed plus 3x squared plus 2x. And then take 1 times everybody. I'm going to stack these again like we kind of showed you last chapter. You don't have to stack them if you don't want to. But there's my 6 dudes. Right? 2 dudes times 3 dudes should give you 6 dudes back. Now I'm going to go combine in like terms. So x cubed plus 3x squared plus 5x plus 2. Yeah, these are the safe games, you know, like Go Fish or at the party that it's just like nobody's getting in trouble playing these games, you know. Add, subtract, multiply. But division is always a dangerous game. It's like Twister, you know. That's a dangerous game. Bad things could happen with the wrong people playing Twister, you know. So let's divide F and G. And when we played division, somebody had to go down to the basement. Right? So bad things could happen. It's hard to tell, though, like who the bad guy is because we need to know what makes this 0. Like we're trying to see what makes this 0. Well, that's been the point of factoring for the past 3 years is if we could get this to be linear, you know, like a linear times a linear, we could easily see what would be the bad guy. So let's try to factor this. Here's an easy factor situation. So would you believe we try to find 2 numbers that multiply together to be 2 and add together to be 3? Who are those 2 numbers? Tell your neighbor. So, yes, they are 1 and 2. So we can rewrite this as x plus 1 and x plus 2 times each other, right? Aren't these the same thing? Right? And, of course, I know you're seeing that the x plus 1 over the x plus 1 are going to be able to cancel each other out, right? Because you got the same thing upstairs and downstairs, but you can't cancel out until you kick the bad guys out of the party. We have 2 bad guys in this situation because what value of x is going to make this turn out to be 0? If x was -1. And what value of x makes this guy 0? So we have to kick them out. X cannot equal -1 or -2. Those dudes, if they go downstairs, are going to cause problems. And here's who the real troublemaker is. Even though -2 is going to cause some problems, -1 is even worse. Because -1, if he like murders people, he's going to cancel those out. You know, it's like, it's stupid. I know I make it up, but it's like, hey, -1's such a troublemaker that they murdered the people upstairs also that look just like him in that case. So we can cancel those out to actually make our final answer 1 over x plus 2. And, you know, it looks like -1's not even a problem anymore, you know. But he was such a problem that he's so sneaky that he would go down there and make people disappear by way of murder, you know. It's like, haha, this is how sneaky I am. So because we're great detectives, we said, well, you need to get out of here before we go downstairs in that case. One of those weird things. So always find your troublemakers before you cancel out is the moral of that story. All right? So, all right, let's go to the back side. Let's check out any restrictions. Why don't you give the video a pause and just tell me who is invited to this party and who is invited to that party. And would you believe, since you've tried that, that everybody's invited to F's party, right? And everybody's invited to G's party in this case. Why? Because there were no X's downstairs and there was no even radicals. So I think that we could play addition, subtraction, and multiplication without any assistance, right? But when you get to the division, we'll do that together. So you pause the video, do these 3 problems, and then we'll do the dividing part together. Okay? So all right, let's get that done. Get the video paused and come back when you're ready. So I got the first one done, where you add these together, and it's a pretty simple game. Watch that x squared plus x squared, you get 2x squared, you know, just watch that stuff, and no restrictions here. And then when it comes to the subtraction, remember that you had to subtract this whole guy away, so everybody's sign changed, so it became a plus 4 in that case. So combining like terms, I got 2x squared plus 6x plus 12. Nobody gets kicked out of the party. Then the multiply, that's a big old maneuver, so I'll get that done here. Okay, so I got this multiplied out, but first I got to go back and fix the mistake that I made on part B. X squared take away x squared is no x squared, so my bad. Thank you for the class for correcting me on that. So it should have been just 6x plus 12. Here, I multiplied all this stuff out, and my like terms is x to the 4th, if I could write, and plus 6x cubed, and plus 4x squared, right guys? And minus 24x minus 32. Nobody got kicked out of this party either, even when they multiplied, because nobody went down to the basement and there was no even radicals to start with. But now it's time for the divide, and this is where people are getting kicked out. So F is x squared plus 6x plus 8, and G is x squared minus 4. We'll probably need to factor so we can easily see who gets kicked out of the party, but it's really about the denominator. It's like you might be able to tell, it's like, dude, it's 2 or negative 2, like they got to get kicked out of the party. It's all good, but we might have to do some factor and cancel anyway to clean this up for our final answer. So isn't the denominator a difference of squares, right? It's a difference of 2 perfect squares, so that easily factors to be conjugates of the square roots. So that's x plus 2 and x minus 2, and there's our bad guys. We got to throw both of them out. X can't be negative 2 or 2. Whatever order you put those in is okay. You know, it doesn't matter, but they're the troublemakers in that case. And then I'm going to have to factor my numerator also to see if I can get some groups to cancel out. But remember, we're kicking people out before we start murdering off any groups in that case. So 2 numbers that multiply together to be 8 and add together to be 6. It ain't 1 and 8. It's 2 and 4, right? So we'll get an x plus 2. My pen would work. Times an x plus 4. And now, negative 2 was such a bad guy that he murdered these people upstairs. That's bad. So we should have checked him on the invite list and said, you just can't go down to the basement. Anytime negative 2 goes to the basement, he wants to kill. Not too bad, right? So 2 and negative 2 are bad guys. And now just 2 more problems, but they're different. So I think we got the hang of things, but now what's different is let's check the invite list. How about F? Who can F invite to his party? Is there anybody down in the basement, or is there any even radicals? So everybody's invited over to F's house. Awesome. But G's got some problems. There's somebody who's not even invited to G's house in the first place because there are some X's in the basement already. And G knows if they invite this one dude over, they're going to cause problems. Who's going to cause problems down in the basement? What value of X would be bad in this situation? 0. 0 can't come over in the first place because at G's house, the party's in the basement. You know, it's one of those things. So we're going to say that X can't equal 0. 0 was never invited over in the first place. So that automatically means that no matter when we combine parties or if we play games like adding, subtracting, multiplying, dividing, 0 was never there. There is a restriction already that says 0 wasn't invited. And people are like, but F said 0 can come over. That's true. F says 0 can come over, but G said nope. And there's no way that G's bringing their party over if 0 is going to be there. Right? It can't happen in that case. So 0 was kicked out from the beginning. Couldn't play any games or nothing because they were never there in the first place in that case. So now let's add these together. So we'll take the 5x squared plus 2 over x. And you know, that's really messy. So we're just going to leave it like that. You know, that's as simplified as we'll leave him. We could manipulate that a little bit, you know, but it's really not any advantage to put it in a different form. So we'll leave it like that. Same thing with the subtracting. I'm just going to go straight to the answer blank. It's 5x squared, take away 2 over x. And there's no real subtracting. And would you believe that even when we played games, I should have done this on the part A, that 0 was a bad guy, right, in this new game plan, but nobody else is bad in that case, you know, but 0 wasn't invited in the first place. 0 would be a bad guy, but 0 wasn't invited in the first place in that case. So now let's multiply them together. 5x squared times 2 over x. And you can see that when we write it like this, before we simplify this, 0 is a bad guy, right? But remember, we've already kicked him out, so we're cool with that. But we need to multiply these together. So since 2 over x was a fraction, I'm going to make 5x squared over 1 a fraction and multiply like so. Numerator times numerator is 10x squared. Denominator is x. And that can clean up, because don't you have some x's upstairs and some x's downstairs in that case? So what would this clean up to be, guys? 10x over 1, which I'm just going to call 10x. And it looks like 0 is not a bad guy anymore, you know, because it's like, hey, you got rid of that guy. But he was there in the first place. To play the game, there was some people down in the basement, and then he was so bad that he murdered some people off, and is sneaky like that in that case. So it's like 0 was still kicked out of the party. They weren't allowed to come over. And then on the last one, let's divide. So 5x squared goes upstairs because it's f, divided by the 2 over x. And this is kind of what we did last time also. Can't do that, you know. First of all, 0 is a bad guy, right, because he's down in the basement causing problems here. But now we've got a fraction in the denominator, and we can't do that. So we'll rewrite it as a multiplication problem instead. We'll take the 5x squared. He's cool. But instead of dividing by 2 over x, what can I multiply by instead? The reciprocal, which is x over 2. So we're going to multiply by the reciprocal in that case, since we were dividing by a fraction. And that turns out to be 5x cubed over 2. And that's how sneaky x is in this division game, was he didn't even, like, make anybody disappear in that case, but he still would blow the function up in that case because you can't divide by 0. So we had to kick him out originally in that case. So it looks like it's okay, but they're so sneaky because when they combine forces, that wasn't good. So only one left, baby. The toughest one of them all. First of all, F's party. Would you believe everybody's invited to F's party? 2. And G's party, we have an even radical. So not everybody is invited. What can't you take the square root of, guys? What is something you can't take in the real number system? I can take the square root of 0, but what can't you take the square root of? Negative numbers. So here's what we'll do. Let's take this homeboy, whatever under the radical, off to the side, just the x plus 2, and let's see if you can tell me what this says. I know you know what that says. It says greater than or equal to 0. Would you also believe, if I said it a different way, can't be negative? Right? If you're greater than or equal to 0, would you believe you're positive or 0? But can't be negative, right? So this right here says x plus 2 can't be negative. Let's solve this for x. What's my move to solve this for x? Subtract 2 from both sides. Does the symbol switch? Excuse me. Does the symbol switch if I subtract 2? So x has to be greater than or equal to -2. This is the restrictions in the domain. This is the invite list that can come over to the party. Any x that's greater than or equal to -2 is allowed. So that goes up here, x greater than or equal to -2. Just for fun, you don't have to draw this, but I will. If I made a little sketch of this and purple note carded this square root function, isn't this the top of the T-Rex's mouth? But it's been shifted 2 units left, right? So here's the graph of this dude, -2, 0, and you make a little top of the T-Rex's mouth, and it's like, hey, if we did the domain, isn't that going like -2 included to infinity? That's exactly what this says, but it's just in a different form in that case. It's like x has to be greater than or equal to -2. So at G's party, everybody that was allowed had to be bigger than or equal to -2. So I'm going to go ahead and put that on all the games we're going to play to start with. Now we might have to modify that a little bit because some more people could get us in trouble, but right now we know that -2 or bigger is the only thing that can come over. Anybody else is going to cause problems in this because we will get a negative underneath the square root, and that's a problem for us. So this is the basic restriction. Let's see if there's more that has to happen when they start playing games with each other. So we'll add these up. 2x plus 7. Sorry, my pen freaked out. Plus the square root of x plus 2. And, you know, that's such a mess. We're just going to leave it like that. You know, it's like we're not going to try to manipulate that. But is anybody else getting us in trouble when we've added these things together? The only place to look for the troublemaker is like right here. And would you believe that didn't go downstairs at all? Right? He's still upstairs, you know, so nothing different than before. It's still the same restrictions. It's got to be like -2 or bigger. So we're good there. Subtract them. It's going to be the same story. You're just going to rewrite the whole mamma jamma, and it will be so messy that you won't need to clean it up. So I'm just going straight to the answer blank. It's the first dude. Take away the second dude. Sorry, this pen is giving me troubles. And because this radical, even though there is trouble with it, we've taken care of the trouble with it. That didn't go downstairs at all, right? So we're okay still. Multiplying this together, put the 2x plus 7 as a group. We can just go straight to the answer blank also if you want to. The 2x plus 7 as a group times the radical. And we ain't going to mess with that at all. We're just going to leave it like so, that, dude, those have been multiplied together. Like taking stuff times radicals. You can do that in FST and in calculus and change it to rational exponents and multiply all that stuff together properly. But that's above our pay grade here in Algebra 2. We'll just leave it like this. And there's no more trouble involved because this guy, we've taken care of him, and he didn't go down to the basement or anything like that. So let's see if we get in any more trouble, though, when we play divide. Let's go down here, 2x plus 7 divided by the square root of x plus 2. And now we could be in a little more trouble because not only was this bad in the first place, but then we went down to the basement and maybe somebody else was bad. Again, would you believe that we could have, when it was just plain Jane McGee here, taken the square root of like 0 in that case? Like you can get 0 underneath a radical, but can you divide by 0 in that case? We cannot end up dividing by 0, so you know how we said anybody that's -2 or bigger can come over? What if x was -2 right here? What would end up happening if we put a -2 in here? You'd get what in the denominator? 0. So now -2 was close. You know, it's like, yeah, you can come over. But now it's like, uh-oh, we're going downstairs now. We got to unleash -2. Can't come over. So all that happens is, goodbye. We change the equal sign. It's like it can't have it. You can't even let x be -2 because that would make the denominator 0. Over here, 0 was okay because it wasn't in the denominator. 0 was okay in all the other games. But down here, since he went downstairs, we had to throw out the dude that makes him 0. So we had to do a little modifying. Cool. Let us know if you have any questions. It's kind of weird, but have a good one.